Welcome to Intro to C Programming. This is going to be an overview of Assignment 7. This function is going to give you experience manipulating strings and using C string functions. We're going to be dealing with palindromes and sub-anagrams. You're going to start off by reading a string from the user. You're then going to determine whether or not that string is a palindrome, meaning that it's the same forwards as it is backwards, ignoring white space. We're going to ignore white space through this program. And we're going to then prompt the user also to determine if they want to enter subsequent words and find out if they are sub-anagrams. A sub-anagram is a word that can be made from a subset of the letters in a word. So if the user selects the sub-anagram option, you're going to prompt him to enter another string, and then you're going to determine if that second string is a sub-anagram of the first string that was entered. If so, you'll tell the user. If not, you'll tell the user which characters violate the sub-anagram property. So there's a few steps embedded in that paragraph there, and you'll see in the sample program that I have below how to go about doing this. We're going to continue allowing the user to enter candidate sub-anagram strings until he enters \Q, in which case we go back and prompt the user to enter the first string again. From that first string prompt, if the user enters a \Q, we will say thank you and exit the program. Our program is going to be case insensitive, so it's not going to matter if we utilize capital letters or lowercase letters. They should be taken exactly the same. What that means, chances are, as soon as you read something from the user, convert it to lowercase or uppercase, because it's not going to matter. Also, it's going to be white space insensitive, so you should probably also iterate through the string that you've read from the user and get rid of all white spaces, either spaces or tabs, so that your program isn't going to have to account for those somewhere else. Okay, there are two cases where a phrase is not going to be a sub-anagram of the original word. The first case is if the sub-anagram uses a character which is not in the original word. The second case is when the sub-anagram, the candidate sub-anagram uses a character more times than it is in the original word. Okay, when prompting the user to enter yes or no, it doesn't matter if the word is entered with capital or lowercase letters. But if the user does not type yes or no, you'll prompt them again with the same question. Your output should be exactly the same as mine. So make sure you're trying to match it exactly the same based on the input. The input here is in bold characters. So it starts off prompting the user, enter a word or phrase or the \Q to quit. I entered race car and I put a space in the middle of it. We prompt the user, say, would you like to see if the phrase is a palindrome? If they don't type yes or no exactly, we prompt them again. So we're going to have a number of loops inside of our program. And when they finally typed yes, and I say the phrase race car is a palindrome. It is the same forwards and backwards if you ignore the white space. Would you like to play the sub-anagram game? And I said yes. You see with a capital Y. That's okay. Case insensitive. Enter a potential sub-anagram phrase. I said Jeff. Says Jeff is not a sub-anagram. The reason is because race car doesn't contain a J, it doesn't contain an F, and it doesn't contain an F. It does contain an E, so we left that one alone though. And then it says enter a potential sub-anagram phrase. So it just goes back, it loops back again and just does it again. Okay, well this time I want to enter care, and it says care is a sub-anagram of race car because you see C-A-R-E is all in there. And then it says here enter another one. I say rarer, R-A-R-E-R. It's going to say it's not a sub-anagram, and here's the reason. Race car does not contain 3 R's. Ooh, that one sounds tricky, doesn't it? How are you going to determine that it doesn't contain 3 R's and then output it that way? Here is my recommendation on that one. What you will do is from your original word, create an array of 26 characters where each element of the array consists of, where each element of the array is an integer, which specifies how many times that character of the alphabet is included in the word. So in this case, with it being a race car, what we would do is the first element, which is element 0 of that array, we would have the number 2. With element 1, which would be a B, we would put 0. With the third element, which is a C, we would put 2. And what we'll do then is that the rest of the characters will have zeros in them. And all we have to do when we're trying to determine if a word is a sub-anagram is subtract 1 from that original array in that specific element of the array for that character. when we subtract 1 off of there, eventually we're going to get to the point that if we're at 0 and we try to subtract 1 off, we're going to say, don't have that many characters. Does that make sense? Okay, so you see then we say enter a potential sub-anagram phrase or \Q. We enter the \Q. That takes us backwards. Enter a word or phrase. We say hello world. Do you want to see if it's a palindrome? No. Do you want to play the sub-anagram game? Yes. Very emphatic yes even, right? Enter a potential sub-anagram phrase. I said Del Row. That is a sub-anagram of hello world. Do we want to play again? We say \Q. Enter a word or phrase. We say \Q. And then we say thank you for using my program. This program is probably going to take you a little bit longer than some of the previous programs that we have written in this class. So I would try to start this a little early. Make sure that you come and talk to me or the TAs if you have any problems or if you have any questions. All right, good luck.